Hi, this video is an introduction to function notation. I just want to start by saying, and I'm going to make this yellow right here, f of x is a fancy way of saying y. This is one of my favorite sayings. It's probably a little bit of an oversimplification because it's assuming that we're using only x and y as our variables, but those are the most basic variables from algebra. But if you think of the entire expression or the entire statement f of x is you've got an f, an open parentheses, something inside of that, usually it's the letter x, and a close parentheses. Let me kind of break that all down for you. Okay, this first part, the lowercase letter here is really just the name of the function, and the most common ones are f of x, g of x, h of x, but you could use it. You could use a letter that represents what the function is. For example, if you're doing a function for the area of a circle, you might do a of x, or maybe even a of r, where r is your radius and a is your area of a circle. And you could do c of r for the circumference. So area a would be represented by area and c for circumference. Just a way to remember which function is which. The parentheses enclose the independent variable. Most commonly, that's going to be your x. But if you think of the whole entire thing, that would be all four parts: the first letter, the open and closed parentheses, and then the independent variable inside. The whole entire thing is a y. So let's go through some examples and see what I've talked about. Okay, so on this list we have four different function rules. Okay, they're all completely different. They have different names. They're all using x as their input or independent variable. One's called g of x. Here we have f of x, h of x, and j of x. So if I go down to problem 1a, it's asking me what g of 1 is. Well, that means looking at this g of x function, what would the y value be, or the g of x be, if the x was 1? So what I'm going to do is I'm going to take that function rule, but instead of this x, I'm going to replace it with a 1, and it just simply evaluate it. At negative 3 times 1 plus 3, well, that's going to be negative 3 plus 3, or 0. Okay? Let's take the second one, f of 3. Well, what that means is I'm going to go over to this function rule, the second one, it's called f of x. I'm going to replace the x with the 3, and I get 3 squared, or 9, and that's my answer for that one. The third one says h of 4. Well, that means I'm going to look over here at the h of x function, and I'm going to replace my x with a 4. And notice I'm putting parentheses around it. That's because when I see 2x, that means 2 times x, and I can put them next to each other without any kind of a multiplication symbol, because one's a variable and one's a number. But the minute I replace the x with a number, I'm going to enclose that. Or it would look like 24, which would be kind of confusing. So now I've got 2 times 4, which is 8. And then over here for number D, this is a little bit different. This is saying find x if, and then it says f of x is 16. Well, what they're saying is if you think of this as a y, it's saying find x if y is 16 over here in this function. And we're looking at the f of x one. So think of it this way. It says f of x equals x squared. So what if I said 16 equals x squared? Okay. What that means is I'm now going to solve for what x value would create a situation where I have y equals 16. And there's actually 2. It's plus or minus 4. Okay. E says find x if j of x is negative 7. Well, j of x, typically that would be your y value. That's negative 7 is equal to 2x minus 1. I've got to solve to find out what x value I would input here, or evaluate this expression with, to get a negative 7. So I'm going to do some basic algebra. Add 1 to both sides, and I get negative 6 equals 2x. Divide both sides by 2, and I've got negative 3 equals x. And the answer is the x value, where j of x is negative 7, is negative 3. Okay? Find x if f of x is 16. And that's actually the same problem as up here, so I'm not going to do that one. That'd be a duplicate. All right. So translate the following statements into coordinate points. So again, just kind of keep in mind this whole thing here is your y, kind of like when we have x, comma y. The part or the number that's inside the parentheses is your x. So I'm simply going to use this as my x. That's going to be my 11, and the other value is my y, 100. It's kind of like I said, the whole thing is my y value. And I'm going to have, this is my x, 21, and my y value is 75. Okay? That's basically saying that when my x value is 21, my y value is 75. There's no rule stated, though. This last one, I've got a 61 as my x value or input value, and negative 10 is my y value, or g of x. Here I've got a negative 33 and a 92. Okay? That's all you have to do to make it a coordinate point. Okay, a couple more. Here's the one where if we're looking at this graph, this whole graph here is a function, f of x, and I'm looking at this curve. Okay, so it says find f of 1. Well, what we're saying is, what it really means is find y when x, so right in here is my x, when x equals 1. So on my x-axis, the place where x equals 1 is right here. And if I go down to the line at that place, I'm going to be looking for the y value right there. Well, I'm going to estimate it because it's between negative 1 and negative 2. It looks like it's a little closer to the negative 2. So I'm going to say it's negative, let's go with 1.6. Okay, that's because this coordinate point right here is 1 comma negative 1.6. Okay. This one here is asking for my y value when x is negative 4. So I'm going to go down here. 1, 2, 3, 4. This is where x is negative 4 right here. And on the graph, at that point right here, my y value looks like it is 2. So notice I'm not putting a coordinate point. It's asking me for, okay, this whole thing is asking me for the y, or the f of x, when x is negative 4. Okay. Here it's asking me for the y value when x is 2. So I'm going to go over here to where it's 2, right here. And on this graph, it appears that that's going to be right there at that point. Come over here to my y-axis, and it looks like negative 2. Okay. All right, now it's asking me what x is when. Now remember, I can think of your whole f of x as being a y. So imagine it's really asking me. Replace that with a y. What is x when y is negative 2? So on my y-axis, I come down here to negative 2 right there, and my x is 2. Kind of like the reverse of question C. Okay, now find x when, okay, now think of that as a y. Find x when y is 4. Okay, so when y is 4, I go 1, 2, 3, 4. Right there. I'm going to go with negative 2. All right. Okay, a few more. Okay, so from this set of coordinate points, so all of these points, find f of 9, meaning what is my y value when, this is my x, when x is 9. So there's a couple important points. There's this one here and this one here. And what they're looking for is the one where my x is 9. So this one over here is a distractor. What's my y when x is 9? Well, that's 2. And that's all I gotta do is put a 2 there. Okay. Find my y, the whole thing, when x is 0. I'm going to come over here. When x is 0, there's only one point here where x is 0. And it's this one, and my y value is 9. Okay. Find my y value when x is 5. I come along here. There's only one coordinate point with an x that's a 5. It's right here. And my y value is a 3. Okay. Find my y value when x is 4. right there. My x is a 4, my y value is a 5. Alrighty. Okay, so find x when, now think of this as you're really like saying y. Find x when y is 5. So I'm going to come along these points. I'm going to find the only place that I see a y value that's a 5 is right here. And at that point, my x is a 4. Okay. Now it says find x when, okay, again, think of this as my y. Find x when y is 7. Okay, so the only point, it's not this one, because this is where my x is 7. Where my y is 7, it's this one right here. And when y is 7, my x is 1. Okay, let's see if we have some more to try. Okay, another graph. These are good to look at. So find my y when x is negative 1. So when x is negative 1, we're right here. My y value looks like it is, I'm going to go with 0.5. Okay, when my x is 0, okay, on this x-axis, this is where x is 0, my y value is 1. Okay, when my x is 2, right there, come up here, looks like right at the 4. My y value is 4. Okay, when my x is 3, what is my y? Well, I'm going to come over here, way, 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 way up here on my graph. Oh, I didn't mean to make that little trail there. Okay. And so again, when my x is 3, my y value right there is 8. All right, now here's a couple different ones. And now they're asking for my x when my, okay, again, think of this as my y instead of f of x. So what's x when y is 2? Well, here's my y-axis. Okay, and when my y-axis is, when my y is 2, right there, x is 1. Okay, now what is my x when my y is 6? So we can go all the way up here. You come across, now look, it's right there. It's a little more, it looks to me like a little bit more than halfway across. So it's a little more than 2.5. So let's just go with 2.6 for estimating. There you go. There's some function notation problems, and thank you for watching.